welcome you all in CEC-UGC Gurukul live lecture. Learners, today in this lecture we will discuss about a very important topic, that is catalyst or catalysis. Why it is important to know about the catalyst or catalysis? Learners, catalysts are the backbone of many industrial processes which can change the raw materials or the reactant into a new products, new useful products. So catalyst plays a very important role in chemical reactions and in industries. Today in this lecture we will discuss about the definition, properties, classification, what is catalytic cycle, catalysis in organic reactions, acid catalysis, base catalysis, metal ion catalysis, what is intramolecular reactions and intramolecular catalysis. So these are the topics of discussion in this 1 hour lecture. Learners, catalysts are also found in our human body, and these are the biocatalysts, and these biocatalysts are called enzymes. So enzymes are the biology's catalyst, biocatalyst. Now what is the catalyst? How can we define the catalyst? What is the properties of catalyst? Why catalysts are important in industrial synthesis? A substance which when added to a reaction, or we can say a foreign material which can add it to a reaction, increase the rate of reaction. And how the catalyst increase the rate of reaction? By providing alternate reaction pathway with lower activation energy. So catalyst increase the when we add catalyst in any chemical reactions, it increase the speed of reaction, and speed of reaction increase due to catalyst provide a different pathway. It can change the transition state which can form during the chemical reactions. Learners, thermodynamically favorable reactions may be slow or modest at room temperature. All the thermodynamically reactions are slow reactions, but they are favorable reaction. We can get a product that there are two types of reaction, thermodynamically favorable or kinetically favorable, but the thermodynamically favorable reactions are the low reaction and it requires larger amount of heat. So due to that, these are not much value for the synthesis, not much value for the industrial purposes. In thermodynamically favorable reactions, we need a high temperature. It means that they require higher energy, and if any chemical synthesis require high energy, it means that the process is very expensive. So that's why industries do not want to use that thermodynamically favorable reactions. Learners, if we wanted to speed up the rate of reaction, any chemical reaction, we have to use or we have to add the catalyst in that reaction. So after adding the catalyst into the reaction, it lowers the activation energy, right? So what is the activation energy? Learners, activation energy is the minimum amount of energy which can activate the molecules or atom. When the reaction takes place, the activation energy activate the molecules or atoms which take parts in during that chemical reactions. So catalyst allow the reactions by lowering the activation energy. How can we define the catalyst now? Catalyst is a chemical substance or a substance that increase the rate of thermodynamically favored or thermodynamically allowed reactions by lowering the activation energy of barrier for the process without itself being consumed. So it is very important part of the catalyst. Catalyst cannot consume during the chemical reactions. A lot of chemical reactions are difficult to happen. So in 90% of these reactions, catalysts are added along the process. And learners, using a catalyst, we can save a lot of energy and time. It means we can say effective catalysts are key driver for sustainable chemistry. In this screen, on your screen, you can see the activation energy without using of catalyst. So in the diagram, it is clearly seen that you can see here the activation energy is higher. So it is enthalpy versus energy. So here activation energy is higher, and when we use catalyst in same reactions, that catalyst lowers the activation energy, which can activate the atoms or molecules. Here you can see the graph and that crest which shows the lower activation energy when we add it to catalyst in that reaction. So the catalyst lowers activation energy. More practice will have sufficient energy to overcome the energy barrier and the reactant. So catalyst, now what is the catalysis? As I told you, catalyst can increase the rate of reactions. Now question is arising here, what is the catalysis? Learners, catalysis is a chemical process which is brought about by the catalyst, right? So the catalysis is the increase in rate of reaction due to participation of additional substance which is called catalyst. So catalysts have a wonderful properties. It promoting proper orientation between the reacting particles. It speed up the rate of chemical reactions, providing alternate pathways with lower activation energy. We have just seen in the energy profile diagram also. It provides the alternate pathway with lower activation energy. It remains unchanged. It means that in the mass and the chemical composition of the reactant remains unchanged when we add catalyst in the reactions. Another important feature of catalyst is it requires very small quantity. A small quantity required in the reactions. So catalyst combines with the reactant or substrate to form a transition states, produce product and regenerate catalyst also. So catalyst we used in the chemical reaction regenerate also. This is also very important feature of catalyst. The catalyst further enters the catalytic cycle and combines the reactant again and again. Catalyst may participate in a catalytic cycle 10 to the power 1 to 10 to the power 6 times or more. And another important feature of catalyst is it does not change the chemical equilibrium constant of the reactions. Another important feature you can see on your screen, the equilibrium approaches earlier. When we use the catalyst, it speeds up the rate of reaction and the equilibrium approaches earlier. So only reduces time of reaching the equilibrium and increase the rate of reaction. Also has optimum temperature. We don't require high temperature when use catalyst in the reaction. Activity of a catalyst can be enhanced by promoters. Promoters, when we add promoter into the reactions along with the catalyst, the activity of that catalyst also enhanced. Catalyst usually loaded on support with high specific area such as activated carbon and silica. One important example where we can see the uses of catalyst is fermentation of carbohydrates or fermentation of agro-based waste which contain carbohydrates, and from that carbohydrate nowadays industries producing biofuels. So industries are using here biocatalyst. As I told you, catalysts are the enzymes. So in that agro-based waste materials, lipase and phospholipids are the major players. So lipase convert the free fatty acids and triglycerols to the fatty acids and methyl esters, and that methyl esters change into cellulosic ethanol. So learners, in the production of biofuels, cellulose are key for digestion of cellulose into glucose, and glucose on fermentation produce or change into biofuels. And as we know, biofuels are the renewable sources. Another important example which we can see nowadays industry using here, catalyst based synthesis of 2,5-dimethylfuran, which is also called DMF. So DMF is obtained from the waste carbohydrate, which is also safe and environment friendly energy source. So the catalyst occupies an important place in everyday life, including chemicals, agrochemicals. So we use the catalyst in the synthesis of pesticides, fertilizers, fuel cells, etc. Also important in polymers, example plastics and adhesives. So in the industrial preparation of plastics and adhesive, industries use catalyst. Electronics learner, in electronics also there is too much use of catalyst that are called electrocatalyst or electrocatalysis. Example platinum and rhodium. So the platinum and rhodium, these are the metals, precious metals, and act as a catalyst. It conversion of hydrogen into electrical currents. Learner, if we're talking about the rhodium here, rhodium is having a wonderful or very potential catalytic properties. Automobile industries is using rhodium, and by using the rhodium it can reduce the exhaust gases which are eliminating, or which are automobiles are releasing into the atmosphere. And learners, rhodium is a very precious metal and it is 5 times valuable and costlier than the platinum and gold, even costlier than the diamonds. So because rhodium having a wonderful catalytic properties, all the automobile industries used the rhodium as a catalyst. Another important example you can see on your screen, electrocatalyst, electrolysis of water. In electrolysis of water, electrocatalyst can promote the reactant energy which is directly converted to electricity. So the electrocatalyst participate in electrochemical reactions and function at the electrode surface. So, in electronic industries, electrocatalysts are using. Another very important feature of catalyst. Catalysts play important role in environmental cleanup. Environmental catalysts are photocatalyst, biocatalyst, electrocatalyst. So these are we can call them the environmental catalyst or environmental catalysis. They are having high potential imperative for a more sustainable future. So that these environmental catalysts limiting the emission of noxious gases from the automobiles. So learners, what are the noxious gases? Noxious gases are the toxic gases which are very harmful for the living beings. Learner, if we talk about the gaseous mixture in atmosphere, nitrogen having 78%, but learner, that nitrogen is inert, invisible. So our lungs cannot absorb that nitrogen. Some of part we inhale, inhale with the oxygen. When we release carbon dioxide, the same portion of the nitrogen gas exhale from our lungs, exhale from our lungs. But learners, in a closed area, when the concentration of nitrogen is increases and the oxygen concentration is decreases, the nitrogen gas is very toxic for all the human beings and all the living things. So these environmental catalysts, removal of carbon monoxide and also used to remove the odors, bad odors from the indoor air. It also used for the cleaning of groundwater. So for cleaning of groundwater, especially iron based catalyst use due to low cost and high safety. Now another important topic is classification of catalyst. How can we classify the catalyst? Catalyst can be classified homogeneous catalyst, acid or base catalyst and transition metal catalyst. So the acid and base catalyst and transition metal catalyst are the homogeneous catalyst. Another type is heterogeneous catalyst. These are the bulk catalyst and supported the catalyst. In this example, you can see the homogeneous catalyst production and transformation of biomass and biomass derived chemicals, and that biomass derived chemicals we can use in pharmaceutical industries, in polymer industries and also used as a fine chemicals. So the reference is mentioned here. If you wanted to see more, look out the more information, wanted to search more, you can go through this reference. Another type of catalyst is nano catalyst. Nano material as a catalyst, metals, semiconductors, oxides which is used the catalyze the reactions, and learners, nanoparticles or nanomaterials are smaller than 100 nanometer in at least one dimension, porous compounds having pore diameters not bigger than 100 nanometer. So these nanocatalysts are very important in many industrial processes. These are having nanocatalysts having wonderful or amazing characteristics. They are having high surface area, very good adsorbent properties. So these nanocatalysts have high surface area, good adsorbent properties, wide range of applications, high catalytic activity, used in natural and synthetic processes, and range of possible chemistries. In different methods we have to use these nanocatalysts, and minimum chemical waste produced during the reaction when we use these nanocatalysts. Another important feature of nanocatalysts are very efficient are in energy. So, energy efficiency is very excellent energy efficiency. Thermally and chemical stable. These nanocatalysts are thermally and chemical stable catalyst. We are using nowadays wastewater treatment. So, wastewater treatment plants nanocatalysts are using nowadays. It reduce when we use these nanocatalysts, it reduce the global warming also, and it means that improve the economy. Also, these are very safer catalyst. Now, homogeneous catalyst. What are homogeneous catalysts? So, you can see on your screen two figures. One is homogeneous catalyst and another is heterogeneous catalyst. So, homogeneous catalysts are soluble in reaction mixture. So, we get only one phase in the reaction. When these homogeneous catalysts dissolve in the reaction mixture, we get only one phase. So, the reaction mixture, they are soluble. So, they require low temperature, more product selective. Product separation is difficult. Why product separation is difficult? Because we get a single phase and the reaction is very expensive due to one phase reactions, and we cannot separate the product easily. In heterogeneous catalyst, insoluble in reaction mixture because two phase, high temperature, less product selective, very economic, and separation is very easy. Learners, next topic is catalytic cycle. What is catalytic cycle? As I told you, catalysts are regenerated, and describing the role of catalyst in biochemistry, organometallic chemistry, bioinorganic chemistry, material sciences. So, the catalytic cycle are written as a sequence of chemical reaction in the form of loop. On your screen, you can see the catalytic cycle in the form of loop. So, the loop, that is represented by loop turnover, TO, describing the one loop through the catalytic cycle. The slow step in a catalytic cycle is called turnover limiting step, and one equivalent of a reactant is converted into one equivalent of product per equivalent of catalyst. And learners, the number of turn through the catalytic cycle before the catalyst becomes deactivated called turnover number, that is TON, and turnover number can be calculated by the formula moles of the reactant divided by the moles of the catalyst into percentage yield of the product, which is in the decimals. So, higher the value of turnover number, longer will be the life of the catalyst. So, in this part we had discussed about what are the catalysts, why are catalysts important in industrial synthesis, and what are the characteristics of the catalyst. Thank you.